So we have this transformation which is called bilinear transformation after this discussion. So HZ, that means any analog filter can be converted to a digital filter by using this transformation, where S is replaced by this thing, where S of analog filter is replaced by this thing, this expression. And in order for HAS transform to HZ, the only condition HZ must satisfy is that it should be stable. HZ should be stable. HZ should be stable. Under the transformation, S equal to 2 by T 1 minus Z minus 1 and 1 plus Z minus 1. Okay, under this transformation, HZ should be stable thing. Okay, so what will be the mode of Z? Mode of Z will be, because this thing can be written as Z from here can be written as 1 plus S T by 2 1 minus S T by 2. Z can be written like this. And when we take its mod, what is S? S is basically sigma plus j omega, that we know. या हम ओमेगा को अगर डिजिटल फॉर्म में लिखते हैं तो कैपिटल ओमेगा से दिखाते हैं. So it is basically mod of 1 plus sigma t by 2, 1 plus sigma t by 2 plus j omega t by 2, j omega t by 2, 1 minus sigma t by 2, 1 minus sigma t by 2 minus j omega t by 2. Okay, इसका mod. And what will be the mod of this thing? इसका mod will be under root of 1 plus sigma t by 2 का whole square plus sigma omega t by 2 का whole square and 1 minus sigma t by 2 का whole square plus omega t by 2 का whole square. Okay, this will be the mod of Z. Now if we examine this, so when sigma is less than 0, this will imply numerator to be less than denominator. Okay, if sigma is less than t by 2, if sigma is less than 0, if sigma is less than 0, this thing will be less, the numerator will be less and denominator will be high. So what will this lead to? This lead to mod of Z to be less than 1. Agree? Okay. And if sigma is equal to 0, then numerator and the denominator will be equal, so that mod of Z will be equal to 1. Agree? And if sigma is greater than 0, this will lead to numerator to be greater than denominator, and this will lead to mod of Z to be greater than 1. Okay, so this is how S and Z will be related in under the bilinear transformation. Under the bilinear transformation. So if there is a S plane sigma j omega and there is a Z plane. This is S plane, this is Z plane. So anything which is on the left hand side of j omega axis, anything which is on the left hand side of the j omega axis will get transformed to, if this is unity circle, so anything which is on the left hand side of the j omega axis will be transformed to inside of this unit circle. So anything when sigma is less than 0, so mod of z is less than 1. It means anything which is on the left hand side of j omega will get transformed to inside of the unit circle. This is unit circle. Okay. And anything which is on the right hand side of the j omega axis will be there in the right outside the circle. Okay. And of course, when sigma is 0, yani ki j omega axis, this j omega axis is basically circumference of unit circle. So what does it means? It means that it is a stable transformation where the left hand side of the S plane transforms to the inside of the unit circle and imaginary axis transforms to the circumference of the unit circle, and half Z plane transforms to the positive half Z plane transforms to the outside of the unit circle. Okay, outside of the unit circle. So it means that whenever HAS is stable, it will lead to HZ to be stable. Okay, because stable HZ means it is inside the unit circle. When sigma is 0, this will imply S. What is S? S is 2 by T, 1 minus Z minus 1, Z plus 1, Z minus 1. So when S, under the assumption that sigma is 0, it will be equal to j omega. S will be equal to j omega, and that will be equal to 2 by T 1 minus e raised to power minus j omega divided by 1 plus e raised to power j omega. Because when sigma is 0, R will be equal to 1. So Z which is equal to R e raised to power j omega when R is 1. So we can write it to be like this. So what will be j omega then? So we can have put a real quantity by taking, if we take e raised to power minus j omega by 2, j omega by 2 common in numerator and denominator, this will lead to j omega to be equal to 2 by T e raised to power minus j omega by 2 and e raised to power minus j omega by 2 and यहाँ पे भी e raised to j omega, तो इसको हम साइन लिख सकते हैं, साइन ओमेगा by 2 and cos omega by 2 so that it will get cancelled, यानी कि 2 by T will be tan of omega by 2 and of course यहाँ J भी आएगा, so J and J get cancelled, so the omega will be this thing, omega will be 2 by T tan omega by T. What is this omega? This omega is analog frequency, and what is this omega? This omega is digital frequency. Okay, because here we have taken S to be equal to omega plus J omega, where capital omega is analog frequency. So this is the relationship between analog frequency and the digital frequency. So when omega is greater than 0, when omega is greater than 0, that means this omega will be in between 0 to pi. Okay, when omega is greater than 0, yani when analog frequency is positive, then digital frequency is between 0 to pi, and when this omega is less than 0, then this omega will be between pi and and 2 pi, between pi and 2 pi. Okay, pi and 2 pi. So the omega can be written as 2 tan inverse of omega by T by 2. So basically it explains why this is a non-linear transformation. Why? Because the digital frequency omega is related to analog frequency omega, capital omega, like this. Okay, so it is contrary to inverse invariance transformation, which was a linear transformation, but bilinear transformation is a non-linear transformation. Okay, bilinear transformation is a non-linear transformation where the infinite axis of omega, capital omega, is compressed to the finite axis of 0 to 2 pi, and this phenomena is generally called warping. This phenomena is generally called warping. Okay, so basically this is the omega domain, and this is the S domain, this is the Y domain. So when omega is positive, it means the upper line, this upper line, it is basically the upper half of the 0 to pi tha na, 0 to pi. Okay, upper half of Z unit axis, and the lower half of omega is basically lower part of this unit axis. Okay, this is what we have seen in this discussion, and this phenomena is called warping. Okay, so this is how bilinear transformation could be obtained by this transformation. S can be converted to 2 by T, 1 minus Z minus 1, 1 plus Z minus 1. This transformation is called bilinear transformation. Okay, so in fact we have discussed two transformations. First was impulse invariance transformation, and second was bilinear transformation, and both of them can be used to